down. The first one that I really had, I shared the Jamboard with you. The first time.
Yeah, yep, I got it. I saw that.
So I know that I need to know the domains and ranges of all like the trig functions. Um, I don't really understand the domains of the trig functions.
You talking about the inverse trig functions?
Yeah, the inverse, sorry. Um,
Okay.
and I don't know the ranges to like cosecant, secant, and cotangent.
Okay. You don't know the domains or the ranges?
So for the domains, I don't know it for any of them. And then the range is just for the other this cosecant, secant, and cotangent.
Okay. I kind of think I know what you're talking about, but let me just see if I've got it right. So you're asking about the domains
Mm-hmm.
of the inverse trig functions, right?
Yeah. Yeah.
Okay. So let's just talk real quick about trig functions, okay? This this is like a very long lesson, so I'll try to go quick
Okay.
and painlessly. So your sine function looks like this. It goes as high as 1 and as low as -1,
Yeah.
and it just goes on forever, right? Boom, 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 in both directions, right? It's periodic. So your domain, so y equals that. Your domain, remember what your domain is. If you could, do you have headphones or something?
Um. Yes.
Because I hear myself in your, are you playing me through your speaker?
Yeah. Here I can put them
If
on.
you could stop that, that would just be easier for the recording.
Yep.
It'll be annoying to hear the echo, probably. So anyway, it's okay if you can't, but if you can, that'd be good. So the domain, you know how your domain is just like you scan it from left to right and you say, when am I going to touch the graph? So
Yeah.
everywhere, I'm always going to touch. So your domain of for a sine function is -infinity to infinity, and your range for a sine function is from, can you see?
Mm-hmm.
Scan from bottom to top. The
Yeah.
range, it's as low as -1 and as high as +1.
Yeah.
You understand that?
Yeah.
Okay. And the reason is because the sine is the opposite over the hypotenuse. And what's always bigger or equal to, which between these is always have to be bigger than the other one or equal to it.
Okay.
You understand the hypotenuse, right?
Yeah.
The hypotenuse can never be smaller than the opposite side because the hypotenuse is across from the 90-degree angle, the biggest side.
Okay.
Okay. That makes sense?
Mm-hmm.
Okay. So, and the same is true for cosine, right?
Yeah.
That's the
Yeah.
same thing for the cosine. Now, how about for tangent? The tangent function, I'm going to graph this on the same graph here. So
Okay.
actually, let me do the cosecant first. The cosecant function is where the sine, it's the reciprocal of the sine function. So here's 2 pi, here's pi over 2, here's 3 pi over 2, right? So
Yeah.
anywhere the sine is equal to 0, what's the reciprocal of 0?
Um. 0. I
No,
don't.
what's 1 over 0? Can you do that?
Oh, 0/1.
No. What's
Like
1 divided by 0?
1.
What is 1 divided by 0? Try that in your calculator. What's 1 divided by 0? What are you going to get? It says error, dividing
Yeah.
by 0. You're not allowed to do that. It's undefined.
Okay.
So you asked me, how do you graph these things? Well, this is wherever the sine equals 0 is going to be an asymptote for the cosecant graph.
Okay. Yeah.
Does that make sense?
Mm-hmm.
And furthermore, the reciprocal of this, the reciprocal of 1, what's the reciprocal of 1?
1.
That's 1. So that's going to be that point. And what's the reciprocal of these points that are close to 0? As it gets closer to 0, like let's say, I don't know, point 1 over 1,000 right here. It's really close to 0. What's the reciprocal of 1 over 1,000?
1,000.
1,000. So it's doing this.
Yeah.
That makes sense?
Mm-hmm.
and it's doing this. So what's the domain of the cosecant graph?
Um,
Let's find our domain. Scan it from left to right. Where is it not defined?
at the asymptotes.
It's not defined at the asymptotes. So the domain of this is all, the domain of this, if I wanted to be really specific, I can say all real numbers except, let's see, let's say it like this. X does not equal, it doesn't equal 0 plus or minus pi times k, where k is an integer.
Okay.
Does that make sense?
Yeah.
Because those are all the places where the sign is going to be equal to 0.
Okay.
Got it?
Mm-hmm.
The range of this, what's the range going to be?
Would it be negative infinity to -1 and then
Very
1 to
good.
infinity?
The range is from negative infinity to -1 with a bracket, a closed bracket, right?
Yeah.
Union +1 to infinity.
Okay.
Okay?
Mm-hmm.
And I'll leave the secant one for you. You can figure the secant out. It's similar to that with the cosine, right?
Yeah. Okay.
Now for cotangent and tangent, it's a similar concept. And I'll just do the cotangent one. And the reason I'm going to do the cotangent one is because the cotangent one, what's the denominator of the cotangent?
Sine.
That's right, it's sine. So wherever the sine equals 0, what's going to happen?
Um, it's gonna be undefined.
It's going to be undefined. So once again, we have asymptotes the same way.
Yeah.
For the cotangent graph, it's the same. Wherever the sign is undefined, there's an asymptote there. Now
Okay.
the graph itself is going to go through wherever the sign is 0, it's going to go through. So there's your graph is going to go through that center point right in between the asymptotes.
Mm-hmm.
It's going to go right between there, and it's going to go like this. The graph is going to go through right here. It's going to go through pi over 4 comma 1 and 3 pi over 4 comma 1. Whoops, sorry, not 1 comma -1. And it's going to do this.
Okay.
So can you see the sign in so the range, what's the range going to be for cotangent? The domain is going to be the same as the cosecant, right?
Yeah.
X does not equal 0 plus or minus pi times k. And what's the
Yeah.
range going to be?
Negative infinity to infinity.
Very
Such
good.
numbers. Yeah.
Good job. I can tell you're smart. That's very good.
Thank
Because I
you.
said that very quick. I just taught you that whole concept in 20 minutes. Now, what you didn't get to yet is the inverse trig,
Yeah.
domains and ranges. Do you want that too?
Yeah.
Yeah, that's going to take a little bit longer. So
Okay.
here, let me add a screen here. So the inverse trig, I'll just give it to you bluntly, okay?
Okay.
Without trying to explain everything to you. Actually, I'll even use this picture. The inverse sine function, we can look at my sine right here. It's going to be from here to here. That's going
Okay.
to be, you're going to flip that basically.
Okay.
Because see how this is continuous?
Yeah.
I don't want to go here to here because that would only be positive numbers. And I can't go
Yeah.
from here to here because then it wouldn't be a function when I flipped it. But if I
Okay.
take this graph right here and I flip it over the line y equals x, it's still going to be be a function, and it's going to be defined. It's going to be 1-to-1, if that makes sense to you. So
Yeah.
this is the fourth quadrant right here, but
Mm-hmm.
going from negative pi. Remember how we can call this negative pi over 2 or pi
Yeah.
over 2. So this is the fourth quadrant right here. This section
Mm-hmm.
is the fourth quadrant. This section here is the first quadrant. Here's your second quadrant. Here's your third quadrant. Again, here's your fourth. Then it goes first, second, third, fourth, etc. And going this way to the left, it goes first, then it goes fourth, third, second, first, right? So if I'm
Okay.
looking at my unit circle, or at my circle, yeah, my unit circle, whatever, this is my fourth quadrant, this is my first quadrant.
Yeah.
My sine inverse function is defined here to here.
Okay. Yeah.
So this is your sine inverse of theta.
Okay.
That's defined from there to there. I can plug in, so the domain, let's see, the domain. No, the domain is anything. The domain is let's see. So remember what this means is what angle this isn't sorry, I wrote an angle in here. That shouldn't be an angle. That should be x. Because this is a ratio. This is like a ratio of like opposite over hypotenuse is basically what this is.
Yeah.
It's like what angle has the sine of whatever this number is, right?
Yeah.
So this number, the domain of this is between -1 and 1,
Yeah. Oh, okay.
right? Because
Yeah.
it's the flip. Look at this right here. The range of your sine function was that, and your domain of the sine was that, but we can't have our range to be, the range isn't going to be everything, because I have to
Yeah.
limit my domain is my domain is anything, but my range is now going to be limited to this section right here.
Yeah. So
So
what it
my range is from negative pi over 2
yeah.
to
Okay.
positive pi over 2.
Okay, yeah.
That makes sense?
Mm-hmm.
And that goes back to this picture right here that I was showing you. That's this region right here. Here's the fourth quadrant. Here's the first quadrant going in negative pi over 2 to positive pi over 2. That's the region that I'm going to flip to find my sine inverse function.
Okay.
Okay.
Oh, okay.
That makes sense?
Yeah.
Your tangent is similar. Actually, let me do the cosine first. The cosine function, y equals the cosine inverse of, remember, this is going to be adjacent over hypotenuse, so this is just some number. And the domain of this is going to be, again, from -1 to 1. So you can plug in anything as long as it's between -1 and 1 to the cosine inverse. Let me prove that to you. If I tried plugging into the cosine inverse a number like 2, it's going to say you can't do that. It said calculator error. You might not have been able to see that.
I saw.
You can only plug in numbers between -1 and 1 inclusive. And the range of this one, let's look at my cosine graph now. The cosine graph, actually, I'll make this in yellow. The cosine graph starts up here and ends up here, and it goes down here, and did I do that right? Yeah, and through here and through here. So your cosine graph does this. And then it keeps going. I didn't do a good job drawing over to the left here. It's going to go through, let's see, it's going to go down here and like that. So your cosine graph, you see how this cosine graph, I
Yeah.
can use the first and second quadrant for this. Do you see how this is positive in the first quadrant and negative
Yeah.
in the second quadrant? So I can use 0 to pi for this one. So that's what we're going to use. We're going to go from 0 to pi. That's how that's defined. So the range is defined from 0 to pi because I cover my positive cosines and my negative cosines with those.
Okay.
And it's continuous. Got it? Well, how did I turn that color? I didn't mean to do that. Okay, does that make sense to you?
Yeah. Yeah.
Okay, so there's 0 to pi. So the tangent one the tangent inverse of, again, this is opposite over adjacent. So y equals the tangent inverse is going to be defined. Let's look back at our graph. The tangent one is the green one here. Sorry, no, that's the cotangent. The tangent one is going to be here. It's going to be like this. It's going to go this way.
Yeah.
So we can use from negative pi over 2 to positive pi over 2. That's continuous. So that's what we're going to use. We're going to go from the domain is going to be, you can plug in all real numbers for this.
Okay.
But the range is limited. The range is only from, whoops, I can't include negative pi over 2. So I have to do an open bracket. Do you know why?
Oh, because of asymptotes?
Because there's an asymptote. Very good. Good job. So that's also right here, but it's an open circle here and here.
Okay.
Got it?
Yeah.
And the cosecant, if you want that one as well, the cosecant is going to be related to the sine. So it's very similar, except with one exception. Do you know the exception of the cosecant? What's the only thing you can't do?
Would it also be because of asymptotes?
So the domain is going to be from negative infinity to infinity, because h is on the top, right? So it can be whatever. Yeah, it's where the asymptote is, which is where is the only place that the opposite is 0. In this blue region, where's the only place where that sign is 0?
At the
It's right there, right? At 0. So the range for this one is going to be from negative pi over 2 to 0, and then from 0 to pi over 2. So it's basically everything but 0.
Oh, okay.
So it's like this.
Right. Okay, that makes
It's
sense.
like the red one. It's like the, I'm so sorry. It's like the blue one, right?
Mm-hmm.
And the red one, but that's open circle there.
Okay.
Make sense?
Yeah.
And the final thing to say would be, I'm running out of colors. So I'm going to go back to green again. Oh, wait. I'm not out of colors. I'd said green, but I did it in yellow. There. I'm going to use yellow for the other one.
Okay.
Can you tell me what the yellow one would be? What would the secant be? It's hypotenuse over adjacent, and what would that be?
For the range, would it be similar to the cosecant, but since the
Yep, you got it.
yeah, okay.
You're thinking what I wrote, right?
Yeah.
So it's from 0 to pi over 2, and then from pi over 2 to pi.
Okay.
Okay, so remember that picture. Remember that picture when you're trying to figure these things out. Okay.
Okay.
So there's that covered. Yes.
Yes.
All right.
So
Now you say, go ahead.
the half angle formula I don't really need. I just kind of put all my questions on there. But what I do really need to know is the third question on here. How do I know when to use pi or 2 pi or whatever when doing the like calculator problems with
So that all has to do with what the period is.
okay.
So the easiest way I can answer this is it depends on the period. You're basically just have to add the period. That's all you're doing. With
Okay.
any problems like this, to write like the infinite number of solutions, just add the period. So the
Okay.
question really is, what's the period for the problem, right?
Oh.
So do you have an example for me to do, and I can show you what I'm talking about? Is that what's over here? You put some on here.
Those were just some extra problems in case we had
Crazy
time.
problems. Okay.
Yeah.
So the simplest answer for you is that it just depends on the period.
Okay.
And unless you have got I can't really think of an example off the top of my head.
I'm gonna try to find one really quick. It's in here somewhere.
Would this be an example of one right here or no? Oh, that was, yeah, this is solving it. Page 5, is that one?
Yeah, I think
Let's
so.
see. This is sine of 2x plus pi equals -1.
Yeah.
Okay, so this might be an example of one. So the way you solve something like this is, yeah. So this, I think this will be an example. So
Okay.
I think how does your teacher teach you to do this one?
I'm trying to remember because this is one of the ones that I didn't know how to do.
Oh,
So,
okay. Well, let me show you how I would do it.
okay.
So we know if this thing right here, the sine of an angle, when is this, what angles have a sine of -1 rather?
3 pi over 2.
That's right. So let's call this thing right here, let's call this u. So I
Okay.
know that u has to equal 3 pi over 2 plus or minus the period of a sine function, which is 2 pi, right?
Okay. Yeah.
So no, let me not do that yet. Let me not add the 2 pi in yet. Let me just do this. We're just going to find the first answer. Okay.
Okay.
So this is going to help us find the first answer. And then
Okay.
we're going to figure out the question that you asked. How do I know the other thing that I had? So now let's substitute this in for u. Right? So u is really 2x plus pi equals 3 pi over 2. So now let's solve that for x. So I'm going to subtract pi from both sides. So that's subtracting 2 pi. So that's pi over 2, right?
Yeah.
And then I'm going to divide both sides by 2. So that's pi over 4.
Yeah.
So that's my first answer, pi over 4, right? Now let's
Yeah.
go back up here and let's talk about the period. What's the period of this function?
2 pi.
No, the period is normally 2 pi, but what happens when you've got this b here?
Oh, would it just be pi?
It's 2 pi over b, which is
Pi. Okay.
pi. So how often is this thing going to come back to that answer of to this answer of -1? What's the period? The period is pi. So what do I have to add and subtract to this first answer?
Pi.
Pi times k, where k is a integer.
Okay.
That make sense?
Yeah.
And
Okay.
in my opinion, that's the easiest way to do those.
Okay. Cool.
Okay, good.
Yeah. Mm-hmm.
All right, let's go backward now and just kind of find problems. Right, as a function of u and v. All right, so this is saying, let me just rewrite this. This is saying sine of sine inverse of u plus cosine inverse of v. Is that what that's saying?
Yeah.
So do we have the identities that we can use, like
Um,
sine a b? I'm gonna look for this one. What's the sine of a plus b equal to?
isn't it sine A cos B and then plus sine A cosine, or sorry, sine B cosine A?
I don't know because I don't have it memorized. Is that what it is?
Yeah, I'm pretty sure that's what it is.
Okay. So that's what we're looking at right here.
Yeah.
Okay. So let's write this out. So we have sine, so this is like my A and this is like my B,
Yeah.
right? So this is going to be sine of sine inverse u times cosine of sine, I'm sorry, times cosine of b. So that's cosine inverse v, right? Plus sine, my b was this one, cosine inverse v,
Yeah.
and my a was sine inverse of u.
Mhm.
Okay, so these things right here are going to cancel each other out essentially.
Okay.
And same with these. You understand why?
Yeah. Yeah.
So
Okay.
this is just u times v plus, as a function of u and v. I mean, that kind of is already a function of u and v. You know what I'm saying?
Yeah.
So I'm not sure what they want us to do, so I'm trying to think of how I can simplify this some more. So this is just the angle. This is the angle whose cosine is v.
Mm-hmm.
And we're taking the sine of that angle.
Yes.
Um, I'm trying to think. Do you have the answer for this?
Yeah. Let me find it in my notes.
I might have to work backward to this one because I'm not quite sure. I don't have the identity sheet in front of me, and I'm trying to visualize what they remember. This just means an angle.
Yeah. So I think the answer is the u times v plus square root of 1 minus u squared and then times square root of 1 minus v squared.
What did you say? Square root of what?
Square root of 1 minus u squared times square root of 1 minus v squared.
Oh, okay. Okay, so what they're doing is they're using so they're using, is there a different formula for that?
I,
For the sine of a plus b? Look
not
at
that
your
I know
formula
of.
sheet. Is there another one that you can use instead of this?
No. All I have
So
is
what they're doing is they're using the fact that cosine squared, sine squared plus cosine squared equals 1.
oh, okay.
So they're saying that, so the angle whose cosine is v, so there's some angle out there, and here's what I have. Here's 1. Okay, this is I think what they're doing, and this is the cosine is the adjacent, and the sine is the opposite. So that's what they're using here. They're saying, here's my angle.
Okay.
And so what are they doing here? The sine of that angle. You're saying that this is what was written here?
Yeah. So like
It was uv plus that.
yeah.
That's how they wrote the answer out.
Mm-hmm. I was really confused on it.
Okay. Okay. All right. No, I got it. I got it. I know how they did it. So look over at my picture.
Okay.
Yeah. So here's what you've got. This is for this picture right here. So I'm gonna draw my angle here, and I know that the cosine is V. So what is this side over here equal to? It's gonna be equal to the square root of 1 minus V squared.
Oh, okay. Yeah, that makes
So
sense.
let's call this A over here. And that's my sine, right? That's the sine of theta.
Yeah.
So to solve for A squared plus V squared equals 1 squared, which is 1. So A equals the square root of 1 minus V squared.
Okay. Yeah, that makes sense.
That's how they did it. So this thing right here equals the square root of 1 minus V squared. And similarly, I could draw a triangle for this one where the sine is U. So here's U and here's 1. So this side over here would be the square root of 1 minus U squared. And that
Okay.
is my cosine.
Okay, yeah, that actually does make sense.
That's what they did.
Okay.
Okay.
Nice. Okay.
All right. Let's see what else. What else? Do you say you're coming back tomorrow for more help?
No, I don't think so.
Oh,
I don't know.
okay. I thought you had mentioned something about a test coming up on Thursday, you said?
I have a test first part of the test is tomorrow, and then Thursday's the second part. But
Got it.
tomorrow's just like the calculator portion, so I have more time
Okay.
to just study.
All right. Well, you have one more question, it looks like here. Let me see if I can do that for you real quick.
Okay.
So this is saying cosine of cosine inverse of 7/25
Yeah.
plus sine inverse of negative root 3 over 2.
Yeah.
Okay. Well, we can find both of these. That's the angle whose cosine, oh, actually, no, we can't find them. That's the angle whose cosine is 7/25, and this is we know this one right here,
Yeah.
right? That's what sine is the y, so that's, which one is that?
I think
Which angle is that on our unit circle?
it's pi root 3, I believe.
So it'd be negative pi over 3.
Yeah.
So this is negative pi over 3. And this is an angle. This is the angle theta. I'm going to draw the triangle in over here, okay?
Okay.
This is the angle theta right here. It's not drawn to scale, such that this is 25 and the adjacent is 7. And so this is 24. That's that angle.
Yeah.
Got it?
Mm-hmm.
So this one, we know those because we do those all the time. So what was the formula for cosine A plus B?
Cosine A plus B is cosine A times cosine B minus sine A sine B.
Minus, not plus?
Yes, minus.
Okay. Again, I don't have those memorized anymore. Okay, good. So this is going to be the cosine of theta. I'm just going to write theta, right?
Okay.
And I'm going to write negative pi over 3 for this one.
Yeah.
Got it? And theta is in that picture over there to the left. This is cosine theta times the cosine of negative pi over 3 minus the sine theta sine negative pi over 3. So the cosine of theta, looking over there, is 7/25.
Yeah.
And the cosine of negative pi over 3 is positive 1/2.
Yeah.
Minus the sine of theta. What's the sine of theta?
24 over 25.
Perfect. And what's the sine of negative pi over 3?
negative root 3 over 2.
Perfect. Good. So now just do the math. So this is 7/20 or 7/50 plus 24 pi or 24 root 3/50, which is 7 plus 24 root 3 over 50.
Okay.
Good?
Yeah. Okay.
All right. So you know how you can find this video?
No.
Sorry, did you say no?
Yeah, I don't know.